So we're talking about your logic gates, beta. In the logic gates, how do you define the logical gates, beta? Electrical circuits using the logical relations between the input and output. Input may be 0, 1, or maybe output 1 and 0, anything like yes and no, false or true statement, that type of logical circuits it will be you're using. In our syllabus, we are having the different types of gates beta in NCRT. One is known as NOT gate. Next one is about your AND gate. Third one is about your OR gate and NAND gate. And last one is about your NOR gate. Clear? Okay. Now see in this one beta, whenever we are talking about two states, in this one, whenever I'm talking about high state or maybe a true state will always represents me the one. And whenever I'm using the low means false, it will be representing me the zero. So logical gates are nothing but they are the part of all the digital electronics. Like say, మనం పోయేటప్పుడు the what do you call that one? Lights on the road, isn't it? Like green, red, and yellow, whatever we are having for the on and off, that all works on the logical signals of the given conditions. Like your electronic items, computer, watches, isn't it? Laptop, this all works on the logical circuits. Clear, beta? Sure. Let us try to talk about the first gate. Sure. First one is about your NOT gate. What do you mean by NOT gate, beta? It is inverse. It is your inversion gate, beta. It is your inversion gate. But if it is S, the output will be no. Like that. The basic symbol of the input is like this. There's arrow mark with a knot on this symbol. So the output will be equal to this one, and this will be the input. Input here, I may be representing it by letter. Like say, for example, A, output will be represented by your Y. And the Boolean algebra for that one is written as Y is equals to A bar. Y is equals to what, beta? A bar. This is your Boolean algebra. Y is equals to A bar. If I take the truth table for that, truth table is a relation between input and output beta. Like say if this is your A and output is nothing but equal to your Y. I told you that if A value is 1, output will be equal to 0. If A value is 0, output will be equal to 1, like this. Okay, this is your truth table for this. Clear? Am I clear? Sure. Next item. So what is the first one I told you beta right now for me? NOT gate. After NOT gate, the next one is you are having your AND gate. What is your AND gate beta? In AND gate, output is I'm taking one. Both in input is right now for me high. If output is low, either input or either output is right now for me low. Let's say the basic symbolic symbolization like D in AND. So it is like D shaped like this. And we get a output here right now Y. And we are having two inputs beta. This is input A and here it will be your input B. So this is your AND. Okay. So in this one, this D symbol is right now in this one. This is like a D shape like this. Okay. So this is your AND gate. Clear? So Boolean algebra for this one is right now for me Y is equals to, we'll read this one as of here, A dot B. So A dot means Y is equals to A and B. So how do we read it beta? Read it as okay. So how do we read it beta? It is read as of your Y is equals to A, and we read this one as of your and we read it as of your B. So this is the way how do we read this? Y is equals to A and as well as of your B. Okay. Like say example, we are having two switches like this beta. This is switch 1. This is your switch 2. Both of them are connected to an alternating source of your current AC. and this is connected to a bulb here right now. Okay, so this is a switch S1, and this is a switch S2. Now tell me when both of them are open. If I write a truth table for this one, beta, I'm writing the truth table for this one. This is your A, this is your B, and here is your output Y. Okay, now tell me, if both of them are open, both of them are open means beta. If they are open, we'll take it as 0. A is 0, B is 0. So bulb will glow beta. This is a bulb. Bulb glow అవుతుందా bulb will glow అవ్వదు ఎందుకంటే both the switches are half లో ఉన్నాయి so y is also equal to your 0. Okay, well, if I'm closing the switch 1, let's say if I close the switch 1 like this, S1 is 1 and B is right now 0. Because there is a flow of current in this one, there is no flow of current. So bulb will not glow. Even in this case, it will be equal to your 0. Clear? Am I clear? Now see, next one is I'm taking this one as of your, this one 0 and this one is 1. Even in this case, it will not glow. The last one, if both of them are closed, this one is also closed right as soon as it will glow. So it will be 0, 0, 0, 1. Am I clear? So switch will close means 1. Switch open means 0. So bulb will glow when it is 1 beta. Else it will be a 0. Am I clear? That means when two switches are connected in series, when both of them are closed, then only the bulb will glow. In all other cases, the bulb will not glow. That is the thing you need to remember for your AND gate. Am I clear with everyone? Sure. The next type of the gate is right now for me your OR gate. Next one is your OR gate. Symbol of the OR gate is like this. So this is your output Y. We are having the two inputs. This is A and this is your B. So this is representing your OR gate. So for this one, the expression we write it as of your Boolean algebra. Y is equals to A plus of your B. Y is equals to A plus of your B. So how do we read it? Read it as Y is equals to A or B. Y is equals to how much? A or B. Or is represented by here what? Plus symbol. Am I clear? Like say here, if I connect two switches in this one, example, see how I'm explaining. I'm taking two switches which have been connected in the parallel combination. Okay. And these both the switches have been connected to an alternating source of your EMF and they are connected to one bulb right now here. This is your bulb. This is your potential, AC potential. This is switch 1 and this is switch 2. Both of them are open. This is your A, this is your B, and this is your output Y. Y is equals to A plus B. So if I take a truth table for this one, roughly I'm drawing. Student. If A value is 0, B value is 0, and both of them are open. Y value is also be obviously it will be how much better right now for me. Both of them are right now open 0 and 0. It will be equal to 0. Okay. If one is closed better, that is like say 1, another one is 0. So if I close this one, is there is a flow of current in this one? But yes, from here there is a flow of a current. This will directly go to this one and the bulb will try to glow for this one. There is a complete circuit like this. So bulb will glow. So it will be equal to your 1. The second case better. This one is also closed right now. So even in the case right now, if I'm taking 0 and 1, in this case also 1, both of them are closed, 1 and 1. So when both of them are closed, even in that case, there is a flow of your current. Am I clear? Am I clear?
Yes, sir.
Very good. Next one. So now we got the three basic gates beta. These three basic gates are known as of your universal gates. One is nothing else of your NOT gate. For NOT gate, the symbolic representation for this one is how much beta? Y is equals to your A bar. If A is 1, Y will be equal to 0. If A is 0, Y will be equal to 1. ఓకే వద్దంటే చేయడం అనేది ఇదే నాట్ అంటే చేయండి రా అంటే చేయకపోవడము చేయకూడదు అంటే బలవంతంగా చేయడం చదవండి రా అంటే చదవరు వద్దు మొత్తం ఎగ్జామ్ అయిపోయిన తర్వాత కొంచెం చదువుకుంటే సీట్ వచ్చేది కదా అనుకుంటారు చూడు ఆ కేటగిరీ వాళ్ళు నాట్లు వేస్తారు 1 and 0, 0 and 1. AND gate D ఉంది కదా లాస్ట్ లో అదే సింబల్ లో ఇది ఉంటుంది అన్న దిస్ ఇస్ డి షేప్ Y is equals to A dot B. It is read as what beta? Y is equals to A and B, isn't it? Like say two switches connected in series combination. The other OR gate, Y is equals to your A plus B. It is read as Y is equals to your A or B. And the two switches are connected in the parallel combination, one above the other. Even one of them is closed and another is open, the bulb will glow. So it is 0, 1, 1, 1 will be the answer for this. Am I clear? Sure. The next one is about your NAND gate. Next one is about your NAND gate. It is a combination of your AND gate plus of your NOT gate. There's a combination of your AND gate and as well as of your NAND gate. What is an AND gate symbol, beta? This is your AND gate symbol. And to this one, you are adding right now for me a NOT gate like this. These are two inputs A. This is your input B. This is your AND gate. This one is your NOT gate. Every time I can't draw this one better. So in order to overcome this one, we are representing it by one single symbol. So this is completely a D shape like this. And to this one, at the center of this one, we are connecting it with your 0 like this. So this is your output Y, and we are having two inputs connected to this one A, and this one will be equal to B. And this will be acting as of your NAND gate. Combination of your AND gate and as well as of your NOT gate. So truth table student account right now for me, Y is equals to your A AND gate key for the given condition. What is the truth table better? So Y will be equal to your, Y will be equal to your, what is the AND gate? Y is equals to, if I'm taking output for this one. So here it is A dot and B. Output will be equal to how much better? A dot B not. This will be the output. So Boolean algebra for the NAND gate is Y is equals to A dot B not. This will be the Boolean algebra. Clear? Am I clear, beta?
Yes, sir.
So what exactly it is doing, beta? It is inverting the AND gate as an output. Like say if I take the logic truth table for that one, A, B, and here it is Y. Y is equals to A dot B. This one is right now for me your A dot B. A dot B bar. Okay. Tell me truth table, beta. Okay, I'll write a little bit detailing. Still, I'll remove this one here. And here I'll take Y is equals to A dot B bar. Okay. Let me see. Okay. Now, children, for your NAND gate, if A is right now for me 0, B is also your 0. So obviously, Y is equals to your A dot B. Y is equals to your A dot B. If it is both of them are 0, it will be equal to how much for me? 0. But output of this one will be equal to how much for me? 1. Not na. I'll tell you later that one. Then it is 1 and 0 for A dot B. Okay. 1 and 0. It will be equal to how much for me beta? 0. Both of them are in series combination. Clear? If this is 0 and 1, even in this case 0. If both of them are 1 and 1, it will be 1. Now what is an output of this one beta here right now you see? What is the output of this one? Anyone? If it is not, the A dot B యొక్క not కాబట్టి this will be 1, this will be 1, this will be 1, and this will be your 0. Clear? That is for your NAND gate. Y is equals to your A dot B. Just like one. Done, beta? And this is also called as universal gate, beta. NAND gate is also called as what for your universal gate. That means from this gate, I can get NOT gate, I can get OR gate, I can get your NAND gate, depending upon the situations. క్లియర్? అమ్మా క్లియర్? చూడండి ఎట్లా ఎగ్జాంపుల్ చూడండి. 9 గేట్ కి ఒకవేళ మన దగ్గర ఇన్పుట్ ఇట్లా ఉందనుకోండి, 9 గేట్ సింబల్ ఇఫ్ ఐఎమ్ టేకింగ్ రైట్ నౌ హియర్, ఇఫ్ దిస్ ఈజ్ యువర్ 9 గేట్ and this is your not, okay, this is your output. If I'm giving two inputs to be the same, say for example this is a, y value will be equal to how much beta? A bar. Y is equals to a bar and which gate it is beta? Not gate. అవునా కదా? This is what for me? NAND gate కదా? From NAND gate I'm getting right now for me not gate. అదే విధంగా if I take two NAND gates like this, ఇప్పుడు అవుట్పుట్ ఏమొస్తుంది చూడండి. So if I'm taking one input here right now A and here I'm taking one input B. Okay. So here not will be equal to much beta? A dot B bar. So output will be equal to much beta? Y is equals to A dot B. So if it is A dot B, what type of gate we are getting beta? AND gate. So రెండు నాన్ గేట్ కాంబినేషన్ యూస్ చేసి ఒక AND గేట్ తీసుకొచ్చానా లేదా? అదే విధంగా if I'm taking the NAND gates like this, ఇక్కడ NAND gate యూస్ చేస్తున్నాం. Okay. For both of them, input is same. That is nothing but A. For this one, both the input is same. That is nothing but equal to B. Then output ikkada A bar. Then output ikkada enta B bar. This both are being connected to one NAND gate like this. So what is an output I'll be getting right now from this one, beta? Y is equals to, it is A bar dot, this is B bar, it is total bar. That means it will be equal to A double bar. When there is a bar, when I'm removing the bar, the dot will become for me plus and B double bar. And you know that Y is equals to A double bar will be equal to A and B double bar will be equal to your B. So Y is equals to your A plus B will represent for me what type of gate, beta? It will be your OR gate. Am I clear? Okay. So that means what I'm telling you right now, from the universal gates, we can get NOT gate, AND gate, and as well as of your OR gate. Clear? Input చెప్పండి తొందరగా. The next one is, next universal gate is nothing but for me NOR gate. NOR gate అంటే ఏంటన్నా? Combination of your, it is a combination of your OR gate plus of your NOT gate. Okay. So basic symbolic representation for this gate is something like this. Like this is your symbolic representation of your NOR gate. With 0 here, and this is output. We get two inputs A, and here it is one input B. So Y will be equal to your how much beta? A plus B total bar. So this will be your NOR gate, like this shape. If I'm getting, that will be your NOR gate. Clear? Then truth table చెప్తారా? Can anyone tell me the truth table for this one? So here it is A, here it is B, and here it will be equal to A plus B, and ultimately Y is equal to how much? A plus B bar. చూడండి. If A is 0, B is 0. Obviously, A plus B is also equal to your 0. For OR gate, if you remember it, what type of the switches we are taking better? Parallel. So if it is 1 and it is 0, so obviously it will be glowing parallel. If it is 0 and it is 1, still it is glowing. If it is 1 and 1, here also 1. Even in this case, it will be your glowing. So it is 0, 1, 1, 1, isn't it? So opposite of this one will be equal to how much better here right now? It is not now, so it will be 1, 0, 0, 0. So this will be the output for this one. That means it is inverting the AND gate. Okay, so can I write here? Inverts the AND, reverse. Done better. And this one is also your universal gate. For pseudo combination, we can get your NOT gate, OR gate, and as well as of your AND gate. Clear, beta? సో ఈ గేట్స్ మనకు సిలబస్ లో ఉన్నాయి బిడ్డ. Logic gates lo AND gate, NOR gate, OR gate, and universal gates are right now for me NAND gate and as well as of your OR gate. నీట్ రాసే వాళ్ళకి ట్రాన్సిస్టర్స్ లేదు నన్ను, కొన్ని ఎంసెట్ రాసే వాళ్ళకి ట్రాన్సిస్టర్స్ ఉంది. Sure. Next one is about transistors. This is for Eapcet only beta. నీట్ పిల్లలకు లేదు ఇది. Okay. So what is the basic function of your transistor beta? It is used to convert the weak signal to your stronger signal. So that is the basic role of your transistor. So what is the basic function? It will work as amplification. What do you mean by amplification beta? It is used to convert your weak signal to strong signal. And oscillation of this one from AC to DC is right now to convert AC into your DC. We use your oscillations. Okay. Now see here, for any transistor beta, rifle చదివింటారు, for any transistors, emitter current is always equals to your base current plus of your collector current. IE is equals to your IB plus of your IC. Okay. IE is your emitter current, IB is your base current, and IC is your collector current. Transistor ఇట్లా ఉంటుంది అన్న. ఇది మీడియం షేప్ ఉంటుంది, ఇది బేస్, ఇది కలెక్టర్, ఇది ఎమిటర్, ఇది బేస్. Okay. So there will be different connections which have been connected to this one. So ఈ రెండింటి మధ్యలో it will act as of your input potential. Between these two, it will act as of your output potential. That is nothing but equal to your V naught. Okay. So current gain for a transistor will be alpha is equals to change in collector current divided by change in emitter current in your common base. That means the base is common for the input and as well as of your output. The same way beta is equals to delta IC divided by delta IB. So this will be in your common emitter. If emitter is kept common, then we defined a beta. Beta is equals to change in collector current divided by your base current. The relation between alpha and beta is right now for me beta. Alpha is equals to beta divided by 1 plus of your beta. Is the relation between your alpha and beta. and beta will be equal to how much beta? Alpha divided by 1 minus of your alpha. So this is the value of your beta. Done beta? We'll define one more very important term in this one beta. Then other derivations are but we don't have time here to do the derivations. So directly try to remember the relations for doing the problem beta. Next one is right now for me your voltage gain. And we are having power gain. So, for voltage gain, if I'm talking about beta, we represent the voltage gain but for both common base and common emitter beta. That is nothing but AV, first formula. That will be equal to your alpha into your R2 divided by R1. This is in your common base. That means base is common for both input and output. The next one is your AV. AV is equals to beta into your R2 divided by R1 in your common emitter. Okay. Then how do you calculate the power gain in the transistors? Power gain in your transistor. Power gain in the transistor is calculated by the formula beta. AP is equals to, AP means power gain, is equals to alpha square into R2 divided by R1 in your common base. Okay. In the same way, power gain of your common emitter condition, that will be beta square into R2 divided by R1. So this will be in your common emitter. Okay. Sure. And one last term, that is about your transistor as an oscillator. Transistor as oscillator. Okay, oscillating between electric and magnetic and electric go on like that. So it is an oscillate. So this is acting as if a transistor amplifier. The positive feedback of this frequency is given by the formula F is equals to your 1 by 2 pi under root of your L into C. This will be the frequency of your oscillator. So this one is known as of your positive feedback. Positive feedback circuit. For negative feedback circuit, better amplification is reducing to distortion. So positive feedback is used as of an oscillators, and negative feedback is being used in the amplification to reduce the distortion part of it. Clear? Am I clear, better? So we got how do you define your alpha, beta, and as well as of a gamma. Alpha is equals to change in collector current divided by base current, and beta is equals to change in collector current divided by your base current. Again, collector current divided by emitter current. Beta collector current divided by base current. Alpha is equals to beta divided by 1 plus beta. Beta is equals to alpha divided by 1 minus of your alpha. Clear, beta? Sure. Take this question, madam. In a transistor used in common emitter mode, current amplification factor, that is beta, is 100, and base current ante IB, base current is 50 microamperes. The the emitter current is, first option is 2 milliamperes, 2.05 milliamperes, 5.05 milliamperes, and 7 milliamperes. First read the question carefully. In a transistor used in the common emitter mode, current amplification factor, that means beta. What is the beta formula? Beta is equals to collector current divided by base current. Current amplification beta is given for me. Given data I am writing here, beta is equals to 100, and base current IB will be equal to your 50 microampere. The emitter current will be equal to how much? Okay, so from this one I can get beta is 100, that is equals to conduction current divided by base current. Base current is 50 into 10 power minus 6. Okay, so how much I'm getting collector current? Collector current is equals to 100 into 50 into 10 power minus 6. So 1, 2, 3. So here it will be equal to minus. So that will be equal to how much? 5 milliamperes is your collector current. But I need emitter current. Emitter current formula you already know. Emitter current is equals to your base current plus of your conduction current. Isn't it? So base current is given how much for me in the problem beta? Base current is 50 microamperes plus what is conduction current? 5 milliamperes. So add them, see how much I'm getting. This one is milli and this one is micro. That makes you difference here. Anyone? 550 microampere plus 5 milliampere ఎంత అవుతుంది? ఇంతనా? This is 50 into 10 power minus 6 plus this is 5 into 10 power minus 3. Okay, 10 power minus 3 common తీసుకుంటే this will be 50 into 10 power minus 3 plus 10 power minus 3 common తీసుకున్నాం కాబట్టి 5. So this will be still 10 power minus 3. 50 into 10 power minus 2 అంటే 5 into 10 power minus 2 plus of your 5. Then ఎంత అవుతున్నాను? 10 power minus 3, 10 power minus 2 milliamperes లో రాసుకోవాలి. 5.05 milliamperes. Then very good. ఇంకో క్వశ్చన్ రాయండి. In a common base transistor, in a common base transistor circuit, emitter current is 1 milliampere beta, and base current is 40 microamperes. Okay, the value of current amplification factor current amplification factor alpha is, chalo చెప్పండి తొందరగా. Giving his options 0.95, 0.96, 0.98, 0.9. In a common base transistor, emitter current is, that means IE is given for me 1 milliampere, and base current is equals to 40 microamperes. Units are different beta. So emitter current is equals to your base current plus conduction current. So I can write here conduction current is equals to emitter current minus base current. Emitter current is right now for me 1 milliampere minus this is 40 microamperes. That means it will be 0.001 minus this will be 0.0004. So this value will be equal to how much beta? It is 0.00096 approximately. So once I know that one, I can calculate the current amplification factor alpha. Alpha is equals to conduction current divided by emitter current. Conduction current is how much beta? 0.3 times 0.96 divided by emitter current is how much beta? 0.001. So simplify this one, we'll get the answer. C under. Hi sir. ఎంత వచ్చిందన్న? It will be equal to how much for me? 0.96. So will be the answer. Clear? So PYQs తీసి ఒకసారి దీనిపైన క్వశ్చన్స్ చేయండి అన్న సతీష్. Logic gates an easy topic. Just try to do the PYQ questions. ఒక క్వశ్చన్ పడితే డైరెక్ట్ యాజ్ ఇట్ ఈస్ గా పడిపోతున్నాను దీనిపైన. సో AND gate, OR gate, NOR gate, XOR gate, one condition. Okay? Sure.